Let us talk about the adjacent channel interference in GSM. So adjacent interference in GSM. What is the meaning of the adjacent channel interference? So as we know, that means we have a specific frequency band, and inside the specific frequency band we have to use those frequency for a BCCH plan, we have to use those frequency for TCH plan. And if wherever we are using, the frequencies, let's say if I am using the F1 frequency over here, I use the F2 frequency at certain distance as far as possible, but sometime due to the limitation of the capacity requirement and the coverage requirement, you have to put lot of sites, and because of the limitation of the frequency spectrum availability, you have to reuse them at the certain distance, right? So you can see here we have two cells, and one cell has F1 frequency, other cell has F2 frequency, and because of the propagation or the height of the antenna, or for any reason, assume that this location where I am standing here, and currently I supposed to get the signal strength or the dominance from the F1, but somehow this F2 is also coming here, so in this location means, when we say adjacent channel, that is C by A, so the carrier divided by adjacent channel. So in this case, uh, let's say the F1 is my carrier, and the F2 is my adjacent channel. So let us see what exactly we have to make the C by A in the GSM. So C by A supposed to be equal or greater than minus 9 dB. What is the meaning of this minus 9 dB, right? So let us simplify this equation more in detail. You will see C, I can write down like C by A. If you maintain even minus 9 dB is good across the network, and here they are in the dB, so I can write down C minus A equal to minus 9 dB. So I can write down my adjacent channel should be C plus 9 dB or less than that. So let's see, take example here. So let us assume that somewhere here where I am standing right now in this particular location, you can see that I am very close to the F1 frequency. So let's say F1 is cell A and the F2 is cell B. Okay, so assume that the cell A is what my carrier right now, and cell B is my adjacency right now, adjacent channel right now. So let me assume the example over here. Cell A, let's say if I am getting NEC 80 dBm, which is considerably good outdoor signal, and let's find out what should be so this is F1 frequency from the A cell. So let's find out that what we supposed to get the B at that location, right? So let's put this, so the adjacent channel, adjacent level of the B should be a negative plus 9 dB, so that is NEC 71 dBm. So you can see the B is my adjacent channel, which is having F2 frequency, is coming up to NEC 71. Still I can say this is a good RF environment where the B is not creating much interference to the cell A, which has F1 frequency. So to understand this, So now the B should be up to B should be or less than equal or less than 71 dBm, right? So what is the meaning of this 71 dBm or less than? Let us draw the standard, the scale here. So this is what your RX level scale, RX level, and let me write down that as you know that it start from neck 47 is the strongest, and the neck 110 is the poor one, right? So you can see here, in my condition right now, my adjacent channel is having 71 dBm, and my carrier, which is having neck 80 dBm, right? So as long as, I mean, if I stay, right, if I stay in this range, if I stay let's say next 70, or if I stay here, let's say next 72 or next 73, somewhere here, I mean in this range is fine. I mean that's okay, means the adjacent cell up to 71 will not create much problem to me, right? But if this adjacent cell B, this is cell B and this is cell A, this is F1 frequency, this is F2 frequency. If the cell B is coming stronger and stronger as I am moving towards the B direction, and then if the cell B is going beyond 71, so it's maybe 70 or maybe 69, or maybe it goes up to whatever level, then it will start creating the problem. So you can see from the scale, I mean up to 70 for this example is I am safe. More than 70 it's not safe. So this is what the green color, if the adjacent stay here, I mean 70 or below 70, I am safe, and here in this range I am unsafe, right? Here is I am unsafe. So this is what the adjacent channel, I mean you should try to reduce the such interference as much as possible, but that means it is not possible, right? It is not possible to maintain this adjacent channel in so many locations. So anyway, but it is not much problematic. The co-channel is very much serious, and we should focus more on co-channel, and adjacent channel we should try to minimize as much as possible, right? So remember this, the co-channel, that is we call it as the C by I, on the same frequency coming from the other cells at the far distance, should be greater than, if you can maintain. Nowadays it is not possible as sites are very close by, and the distance of the intersites are not much more than 400, 500, or even some cases even less than 300 meter in the metro towns or the dense cities. And C by A should be equal or greater than NIC 9 dB. So please remember this too, I mean this is co-channel, this is adjacent channel. Now by understanding the co and adjacent channel, this is the entire activity what you need to do in the optimization, is to manage this co-channel and adjacent channel interference. You have to manage this interference in the GSM, right? So the RF engineer has to ensure that you maintain this co-channel as low as possible throughout our area, and if possible to maintain the adjacent channel also, right? So this is what about the adjacent channel interference. I will explain you more about how this to achieve the interference within the limit. Okay, so let's see in the next lecture.